Afternoon, Simon Dan. How are we? Happy Sunday. Science Sunday. There was a time when you could say, where's my moon gone? But I bought a dozen the other day at the op shop for a couple of bucks and just spread them out everywhere. So now I always have a moon handy, which is handy because gravity, discovered by Newton in 16 something, probably 1666, and all because of an apple. He saw an apple fall from a tree and went, lo and behold, that apple, it reminds me of the planets. Gravity, the sun, we are all revolving around it. That's how it came to be. We are spinning. We are spinning around and around. And we're spinning in a bulge of water, aren't we? That the moon is creating. Where's my stick? I might need to reach out and hit somebody in a minute. We are spinning in a bulge, aren't we? Even though there's quite a fair bit of Earth, somehow there is a bulge there as well. Now, first up, if this were the moon, has a diameter just under 4 centimeters. So I opted for a planet Earth that had a diameter of just over 14 centimeters. Now, if that were the moon, you know I like to do these things to scale to show how stupid they are. See that ping pong ball there? It's to scale with the little Earth. Earth that has 14 and a bit centimeters in diameter. To scale, give or take a gnat's whisker, okay? Earthquake. Sit. Now the other Earth, the bigger one of the two, that is to scale with, you must be familiar with this moon, 8.3 centimeter moon. Now, let's do that common sense bit. You honestly think that that moon down there is somehow creating a bulge on the front of their planet that is spinning? Not only is it creating a bulge this side of that planet, it's also attracting the planet itself that moves into that bulge. The bulge still stays, but that little tiny moon, that little powerhouse, actually pulls on Earth, and Earth comes a little bit towards us, moves into the front bulge, that creates a bulge at the back. Now, I mean, look, let's go back inside where I'll have my stick, because I can feel it coming. I can feel me reaching out with the stick. A little ping pong ball, it's doing all of that over there, not affecting any of the smaller bodies of water. Look at that. I have to get used to that. So, now this is what you are believing. And when somebody points out what I'm about to point out, you think that person is not speaking much logic. It's not making sense. And you throw your little teddies in the corner and accuse me of talking rubbish. That's better. Right. First up, you've seen the scale. You've seen the scale, the distance. This bulge, and the bulge at the back, this is pulling on that water. One would think at 299,000 792 kilometers per second, the speed of light. So it would take what, 1.3 seconds for, we're spinning in the bulge. And that is creating high tides along here, low tides there, low tides there, and somehow at the back, high tides, because as the moon's pulling on that water, because the water's closest there, it also pulls on Earth a bit. And that creates a bulge at the back. And because, it's so stupid, because the force of the moon is strongest on this water here, right? It moves forward. Planet Earth moves, stop it, slowly forward. And at the back, the water gets left behind. And it obviously comes back a little bit, but because the moon's gravitational pull is not as strong at the back, you get a bulge at the back. Now that would suggest this Mickey Mouseness right here, that here and here we'd have low tides. Wouldn't it? That's what it's saying. Moon's over here, the bulge is here, and the top and the bottom would be having low tides because of the bulge. Now, would that not mean that there would be forever low tides because the bulge is always here? Well, it would do if common sense and logic were involved. Also, that bulge that's here, the Bay of Fundy, Ngava Bay, the Bristol Channel, the Cook Inlet, all of those places are at the top, aren't they? So this bulge, the back and front bulge, what is that all about? It doesn't seem to have much going on, does it? And why is it that where the bulge is, there's no action in the Gulf of Mexico or the Mediterranean Sea and the Bahamas, I hear? In fact, all along the equator, there seems to be a lack of action. Why is that, Simandan? Why? The topography, the way everything is spread out on the bottom of the ocean and stuff. Listen, you can keep denying all of these facts and keep believing that the moon somehow has something to do with the water. But it obviously hasn't. It just hasn't. There is no pattern to be found. The high tides and low tides are spread out equally everywhere. You live in the UK, check your tide charts. Scotland, all the way down the coast, all the way down to Cornwall, on the west coast, all the way down Southampton, Brighton, up to the east, and then Mersey on your way up, all the way up to Scotland again, all the way up the coast. You'll see that there are high tides and low tides. How is that possible? Why, if this is happening, why is that possible? Why is it that every single continent, all of these countries all over the globe, have high tides going on and low tides going on at the very same time? Why is that? How do you link that, what's happening in real life, with what's happening with the moon and the position that it's in around Earth? How do you link these two together when there is zero pattern? How do you do that? What is it that I have to do to end up believing something so illogical? I'm curious. I want to know why. There is no pattern, Simon, there. To suggest there is, who knows? Who knows how that happens? All right, we're going to keep that at sub 10 minutes. I will be back. Laters, peeps. Happy weekend.